All right, so first some housekeeping items. I mentioned this just a little while ago, but for the folks just walking in, our last class in this class before the holiday will be Thursday. We don't have any class a week from today. So, that'll let us start our holiday a little bit early. So Tuesday's schedule is, or next Tuesday's schedule would be based on the usual Friday schedule. So the only reason you have to come in on Tuesday is if you generally have classes on Friday, but we will not meet on Tuesday. So just to make sure everybody knows that. The other piece of housekeeping is now is a good time to check your grade in Canvas. And the reason I say that is as of today through Thursday, you have three options for this course. Option number one, and my preferred option, is that you commit to do the work that's necessary to pass this course. That's option number one. Option number two, and this is my least preferred option, is that you don't commit to do the work that's necessary to do this course and you fail this course. That's my least preferred option. The option that's in the middle through Thursday is the withdrawal deadline. So the withdrawal deadline for this class is Thursday. And I don't like to see people withdraw from this class because, like I said, my reason for being here at this school is to pass along the knowledge that I've gained, and I want to see that done successfully. So whenever somebody doesn't pass this class or withdraws from this class, I feel like I failed. So, that's not my preferred option. But withdrawal might be a preferred option for some versus failing the class. So, I just want to put that out there just so everybody knows. And as I said, my preference for all of you, my personal preference is that you commit to doing the work that's necessary to pass the class and get the grade that you want and deserve, and you learn something besides. So that's my commercial message here. All right, so today what we're going to do is we're going to go over some of the intermediate SQL SQL stuff, the stuff that was on the exam and the stuff that was in our last homework. So we'll start with the exam. And one thing I should mention about the exam is I did make it closed book and closed notes. In retrospect, I think next time I do this, I'm going to make it open book and open notes. Because, I know a few people struggled with some of the syntax and things like that. And some people struggled with some of the specific queries. So we're going to go through that today. So, let's start off. This database, hopefully this database was at least somewhat familiar by virtue of it being part of our ERD lesson. So, we had a description of the database here. We had a diagram that showed how these things were related, the ERD. And we had the logical schema. And you were asked to create some queries based on this information. And the first query that you were asked to create was a simple join. And when we talk about doing simple joins, we usually talk about the same thing. We talk about first identifying the fields that are necessary. And the good news is those were pretty much provided. And obviously, we have to make sure to put the square brackets around the ones that have spaces in them. That's something we certainly have to do. And to the extent that any of these fields appear in multiple tables, we have to keep that in mind. Just make a note to ourselves that if there are any of these fields that appear in multiple tables in the description above, we may need to specify specifically which table they're in. So we're going to select these fields, and the tables that we need have to include last, first, middle, street address, city, state, zip, and school name. So the tables that we need here have to include karate student, and the school name is in school. So, here we're joining karate student with school. And the thing that those join on is school ID, which is a common field to both. So we can say from karate student join school on karate student dot school ID equals school dot school ID. Okay. So that puts these tables together, and it gives us the tables that we need. You know, we can make that, indent that nicely. And we need a criterion here. The school name is Middlesex Karate School. So we can say school dot school name equals. You guys use double quotes. I didn't really penalize you or anything, you know, but you know, people server uses single quotes. Where school name equals Middlesex Karate School. And then it says ordered alphabetically by last name. And, you know, that's essentially the answer to the first query. And I would say that the vast majority of you got this right. And that was worth 10 points. But you had to have all those elements, you know, the field, the join predicate, the select predicate, and the order. Okay. Now this one kind of surprised me a little bit. A lot of people had a lot of trouble with this one. So, you know, I want to make sure we go through this together because this one, you know, this is, yeah.
Why do you have to put the school name on the first one? Oh, wait. Never mind, you have to, okay. I see.
Okay. Okay. So now we have the all word, you know, and I made it clear in the title of this query that we needed to use the all keyword here. So what we're going to do, once again, you know, this is a select statement. You know, it lists. And these are the things that we want to include. So we'll just copy and paste those down there. And, you know, once again, we need brackets around the things that have spaces in them. And the tables that we get this from, you know, we know last, first, middle, you know, all of those come from karate student. So we need karate student. And if we go up, we see, you know, we can either look at the picture, you know, karate student earned a rank, you know, we can see that. And we can see that there's a table here called earned rank, because that's a many-to-many relationship, you know, with karate student earned a rank. So we need earned rank because that tells us the rank. And the thing that joins those is the karate student, I'm sorry, the thing that joins those, let's double check this. Earned rank has the karate ID. So that's the thing that's going to relate these things. So we're going to say on karate student dot ID equals earned rank dot So that we certainly need. Now, earned rank does not have belt color. Let's double check that. See, earned rank does not have belt color. We need belt color from rank. So we need rank in there also. So we need to do another join here. And the thing that relates earned rank to rank is earned rank dot rank ID equals rank dot rank ID. So those are our joins. But now we need a condition here. And the condition here is that the rank number, which is in rank, has to be greater than any other rank number. Is greater than or equal to all something. All what? What is rank number greater? What does this rank number have to be greater than or equal to? Well, it has to be equal to, greater than or equal to the list of all rank numbers. How do we get that? Well, we need a select statement. And that's our select statement that we need. We select, from lower, from rank. Careful of your syntax here. Okay. So this gives the list of all ranks, all rank numbers. And in this case, rank number is greater than or equal to all of those rank numbers. So that's one way we could have done this. And that's actually the preferred way. Does anybody have any questions on this way? A lot of people didn't know what to put in the all statement. So hopefully this helps you all on what goes in the all statement. Okay. So can anybody think of any other way we could have done this? Alternative. So you guys actually had two ways you could have gotten this right. Let me copy this down here. That's another way you could have done that. This was way number one. That's using all, which is what the query required.
Why did less greater than or equal to all?
Because in order for that rank to be the highest rank, it has to be greater than or equal to every other rank. Yeah.
So I did the right thing, just didn't use all.
I guess the greater.
Yeah, if you do greater than, it would return nothing. Because there's no rank that's greater than all the rank. There's only a rank that's greater than or equal to. Okay. So greater than is not correct in this query. if the ranks are, say, 1 through 15, the rank that would be greater than 15 would be 16. Does anybody have any questions on either of these alternatives? Okay. Outer join, all right. So this one, I will admit, was kind of tricky. And I gave very lenient credit for this one. But, you know, what we want here is we want all students and all events. But there will be some, if the student didn't attend the event, then we want to know that the student did not attend the event by a field being either having a value or having none. So how can we do that? Well, if we want the combination of all students that attended the event, or all students and events, if we want all combinations of all students and events, I would say this is probably the hardest query. This was the hardest query in this. Okay, so first we have the fields. And we've got to keep in mind that one of these fields in particular appears in multiple tables. Which field appears in multiple tables?
An ID?
Event ID, yeah, event ID appears in multiple tables. So we'll make a note to ourselves, or we can make a notation here that we're going to need to say which event ID we're using. So I'm going to put a little square bracket there, just to get us ready for the fact that we're going to have to say which event ID we're going to use for this query. All right, and the things that we're joining here,
You know how to write from?
wait,
So do you know how to write from and?
yeah, you do have to write.
Okay.
I'm getting there.
I was just making sure.
Yeah. So the things that we're joining here are karate student and event. Let's start there. Now, the interesting thing about this is if we do not put a join condition on this, let's even get rid of the word join. If we do not put a join condition on this, we get every combination of karate student and event. Okay? Essentially, this will give us a cross product, you know, which we've discussed in our relational algebra. This will give us a cross product of karate student and event. So we will get every single combination of karate student and event. Okay, and that's what we want. It says there's a record for each student and each event. So this creates the record for each student and each event. Okay, but what we want here is we want to know whether they attended the event. So we need the attendance table. And here we want to know which records match the event ID in attendance. And we also want to know in attendance So, make this a little bit more readable. So attendance has to match both. Attendance has to match both the Karateka ID and the event ID for that karate student to have attended. Yeah,
So I thought you would have to do like full hour join and like the name of the join, not like left join and just join.
well, you could do a full hour join here. You
Okay.
could do a full hour join here. But what you really want is, since, there is no record that you're gonna get in attendance that isn't part of the total combination of students and events.
So attend has both of everything?
No, that first join gives you every combination of karate student and event, right? So that's everything. Okay? Attendance is only the ones that they attended. Okay? So you want to include everything. And if they attended, then attends.event ID.
Oh, that's where the left join comes in, because then all of the ones they attended get inserted into it.
Yeah, all the ones that they attend, for everyone that they attended, this will have a value.
Okay, and it won't be null.
Right, for everyone that they didn't attend, that one will be null.
Okay.
Does that make sense to everybody? Does anybody have any questions on this? So this query would tell you all the events. And for the ones that a student attended, it would have a value here, the event ID value. And for the ones that the student didn't attend, it would have null in there. Okay? Like I said, this one was probably the trickiest of the bunch, and I graded it very leniently. But does anybody have any questions on this query? And yeah, if you did a full outer join here instead of a left join, it would work. But the only reason it would work is because joining those first two tables creates every possible combination, and there would be nothing missing from there anyway. You know what I mean?
Mhm.
Okay. Most of you got this one right. I'll go through this, but this is create view. And it starts with a create view statement, and you name the view. Okay, and once again, I make it real easy, I hope. To get these field names in here. Pretty much cut and paste and putting the brackets around it. And in the question, I make clear that we're talking about school street, school city, school state, and school zip rather than Karateka city, state, and zip, because you need to know that. Okay, so we have our fields here. Just to make it look nicer. And of course, my WebEx tool is in my way. One of these days, I'm going to figure out the reliable way to get rid of that WebEx. There we go. All right. All right, so those are the fields that we're selecting. Yeah, I gotta put brackets around. Okay. Great. And we're selecting these. We need karate student. Join school on karate student dot school ID equals school dot school ID. And we also need federation. And federation, if we look up here, we haven't used federation yet, so I'm going to double check, make sure. And what I see is that the school table has a foreign key of federation, federation ID. So that's what we're going to join on. By the way, I do have an answer sheet with this, that has all these things. And I'm just doing this to show you the process. Okay, so you join with federation. And we need a where clause here. Federation dot federation name equals American Shokai Federation. And that's that query. Does anybody have any questions on creating a view? Okay, this view was important, because you need this view so that you don't need to do a whole bunch of joins in the next part. Okay, so I wanted to make this easy for you. The next one reasonably easy for you by establishing a view that had the fields that we needed, so you didn't need to do a join, a lot of joins for the next query, which is a union query. And this one was probably the second trickiest query in this text, because union queries are by their nature fairly tricky. So what this said is it wanted a union query that showed all the matches that were won by a member of the American Shukai Federation as Aka, and the number that was won as Al. So here we go. These are the fields. So let's start there. Let's put in our first select statement. Select. And we can get all these fields. Once again, a simple copy and paste. And we have to put our little brackets around it. And match ID right there. Okay, and the tables that we need for this, or the views and tables that we need for this. Well, everything that we need is pretty much in that view that we just created, which is called, double check, ask you students. Let's get from. And the one thing that's not is the match ID and the winner, that stuff is not there. That stuff has to be in something else. And when we look up here, we see that the match ID and the winner isn't match. So we're going to need to join this with match. And what are we joining it on?
Every single time you do a join, you have to add on.
Yeah, if you use the word join, you have to use the word on.
Because, I don't think I used on, but you didn't take slints off, I don't think, I'm not sure. Okay,
Unless you want me to take the points off.
I'm good.
Okay. I think I might have taken them off earlier and I decided not to penalize you twice for the same thing. That's probably what happened. All right, but the thing that we're going to join it on is ask you students.karateka ID. But the first part of this query, we want to know where those karateka were aka. And where the winner was aka. So that's the first part of this query. You know, when that student from Ask You Students was aka or red, and the winner was aka, they won. But they also won when they were ow. So when they were the ow karateka in the tournament, and the winner was out. Okay, so that's the union. And then we had to order this by last, first, and winner. And you know, if you did the order twice, I didn't take off, but when you order, you only need to do order at the end. You know, for a union query, you don't need to do it for each part of the union query. So this was the answer to that question, to that test question. Does anybody have any questions on this? Okay. Now, the third hardest question, apparently, was this one with the sum query. Out of my way, WebEx tool, I need my indents. There we go. All right. So this one was an update using a sum condition. And it said update title to sensei for all teachers who have earned a rank number greater than or equal to 15. So let's do that. Update. And the table that we're updating here is teacher because that's what contains the title. And what we're doing is we're setting title equal sensei. Oop, single quotes. That's the update that we're doing. And now we just need to say when we're going to do that. And the time we're going to do that is when there's some equals some where their karateka ID equals some karateka ID from earned rank where let me double check. Okay, I need rank number, so I need to join it with rank. From earned rank, join rank on rank ID equal rank dot ID, where rank number greater than or equal to 15. Careful with the brackets. There we go. So this subquery gives all the Karateka IDs for anybody who's earned a rank greater than or equal to 15. You know, that's what this subquery does. This subquery gives you the list of all Karateka IDs for anybody who has an entry in earned rank that corresponds to a rank number greater than or equal to 15. Okay, so you need that subquery to tell you who has earned a rank greater than or equal to 15.
So the subquery is inside the sum? Okay.
This is the subquery. Okay, so, you know, we can offset that subquery. So this was essentially two queries in one, right? There's an update query that updates the title to Sensei. But it only does that if the Karateka ID is equal to some Karateka ID that's earned the rank of 25. I mean, of greater than or equal to 15. Any questions on this one? A lot of you had trouble with that one. Okay. Cascade deletes. All right, to add any constraint to a table or any foreign key to a table, we have to alter the table. And we want to alter the table teacher. In fact, the words of the question said alter the table teacher. Some of you didn't know do an alter table here. So, you know, this is the first thing we have to do is we have to alter the table. And what we're doing is we're adding a constraint. We're adding a foreign key constraint here on Karateka ID in teacher that references karate student Karateka ID. And then we add that constraint on delete cascade. Okay, so when we set up a foreign key, we can say on delete cascade, we can say on update cascade. Okay, what that means is that if the record in the referenced relation gets deleted, then the record in the referencing, corresponding record in the referencing relation will get deleted also. On update cascade means if the relation in the, or if the record in the reference relationship gets updated, so will the corresponding records in the referencing relation. Okay, so this was the answer to number 7. I just named it something. You could name it anything. Okay. So, you know, I gave it a name. I called it teacher cascade delete. You could call it anything you wanted. And a lot of you forgot the alter here. A lot of you forgot the foreign key constraint. So, this one had very mixed, results. Write an integrity constraint to check that no rank number in rank can be greater than 20. And if it can't be greater than 20, it means it has to be less than or equal to 20. So, it not just less than 20, less than or equal to 20. I might have subtracted a point if you left off the equals. But the other thing that some of you did, which is also valid, is you left out the add constraint and you just said check rank number less than or equal to 20. I think SQL Server accepts that. I think that's syntactically correct as well. So I graded out incorrect if you did not use the add constraint. And once again, max rank 20, I just named that. You can name it anything you want. But that was the answer to number 8. Any questions on that? Any comments on that? Okay, the last one was worth 20 points. And the important thing on this one was that you needed to have both statements in a try, because if either one of those failed, you wanted to be able to take action to roll back those statements. So, the first one said update title to Shihan where product ID equals 7. And the second one was inserting to rank values 25 and gold, gold belt. And, we had an earlier constraint that said the rank couldn't be higher than 20. So this one would have failed with that constraint. But, if you have these two things, you need them in a try statement, because what's going to happen is if either one of these things fails, it's going to raise an exception. Okay, so you wanted that exception to occur somewhere in this try statement, at which point you would execute the catch statements. Okay, so if either of these fail, what happens is anytime a statement fails, the rest of what's in the try does not get executed. It jumps into the catch. Okay, so you needed the try and catch to make this work, because if you got through these statements, you commit the transaction. But if either of these statements failed, you jump down to here and roll back the transaction. And that's the basic format of the transaction. And if you got this, if you got this structure and you had both statements in the try and you had the rollback and the catch, you got full credit for this one. Any questions on the test? Yeah.
Maybe I'm thinking Java, but I'm trying to think else. And that's incorrect. So I was like, was there a way to actually?
No. The thing about ifs and elses is every statement gets evaluated. And actually the if condition generally doesn't test for an exception. It tests for some condition that's met at the time of the if. So it will not jump out. It will not jump out if there's a failure. But this kind of, this is branch execution. It's executing one branch in one situation, one branch in another situation. But exception handling doesn't work with ifs and elses in Java or any other language. All right, so that's the test. And, I was very lenient in the grading of the test. What I did was I multiplied your grade by, instead of multiplying it by 3 and taking it out of 300, I actually multiplied it by 4. So if you got a 74 or above, you got full 300 credit for 300 points on the test. If you got below a 74, you got, whatever 4 times your grade was there out of 300. And some of you didn't need that. One or two of you did an awesome job on this test and really knocked it out of the park. And I don't want to embarrass anybody, but they know who they are. So good job to those of you who didn't need the extra 1 times multiplication. And the other thing I should mention is that in each of your tests, when I graded it, I attached my evaluation of your test as an attached file. So if you have any questions on what was subtracted, you should see all the details there in that file. Okay, any other comments or questions on the test? Okay, I'm sorry that, from my perspective, I think the sum and the all I could have taught a little bit better, because I think a lot of people had trouble with the sum and the all queries in particular. That one I feel kind of bad about. That's the one I feel kind of bad about, is that I didn't do a good enough job teaching sum and all that you guys knew how to use it when the test came. So I made that up by multiplying your grade by 4 instead of 3. All right. But hopefully, as a result of reviewing this test, you now know how to use sum and all. Hopefully. Let's go over the homework. By the way, if you don't know how to use sum and all at this point, please let me know and I will do a refresher. All right, let's go into our homework assignment now. Notice what a pain in the neck this X tool is. Okay, use left joins to create a table of geographic areas with a description of their rural-urban continuum code, urban influence code, and ERS topology. Make sure to include all geographic areas, whether they have such descriptions or not. All right, so here are our fields. I'm going to create a new query here. There we go. Select. Those fields. Got some line breaks in here so we can see what we're doing. Okay, and the tables that we would select those from, we can see here. And the good thing about this homework is, unlike the test, you should get immediate feedback as to whether you got it right or not, whether you got the query syntax right. Okay, and the tables that we're selecting this from, we need geographic area. And we're going to left join that with rural urban continuum code on
Did they intermediate SQL homework?
Yeah, this is the intermediate CP1. Equals. That's that foreign key. Left join, urban influence codes. One. Practically helps the query write itself. And then lastly, left join ERS county typology on traffic area dot typology. ERS county typology dot. And we need to order this by anything. Let me look back on the thing. Nope. And hopefully if I did this correctly, I get a table that looks like this. And it has null, null, null for United States, and it has values for everything else. Except for some of the states don't have values. So that was the end result of that first homework question. And, you know, as long as you did a left join and you knew which table or which fields were the primary and the foreign keys, you got that one right. Okay, next one. Create a view named Ocean County View of all population metrics for Ocean County, New Jersey, i.e. where the area equals Ocean County and the state equals New Jersey. So you would go here. Hopefully, let me make sure I don't have that view already. I was checking your homeworks. No, okay, good. So now these are the fields that we're going to use. So we're going to create Ocean County View as, and similar to the view we just created as in the test, we select this from, and we need geographic area. I can type. And we need population metrics. That has all this other stuff. Drawing population metrics. And we're joining that on FIPS number equals FIPS number. And the beauty of this, once again, is that SQL Server makes it very easy to fill these things in. And we need a where clause here, where area equals, quote, Ocean County, and state equals Jersey. Hopefully if I type all that right, oops. I did not. Forgot the word view. There we go. There we go. So this would create the view. Anybody have any questions on this query? Okay, so that was the second one. Copy query 2 into the separate file and delete the portion that creates the view, leaving only the select statement. That's a gimmick. I'm not going to do that one because I just did that one and I don't want to do it again. All right. No. All right, number 4. Create a query that shows all records in Ocean County view. This one was also a gimme. We're going to create a new query. And this was select star from the view we just created. That one was pretty easy. Okay, the next one adds 10 to births in 2012 in Ocean County. Okay. So we're going to hold on to this query. We're going to create a new query here. And we're going to do an update. And this one, second. We'll make sure I get the right column name here. Metric value. Set metric value equal metric value plus 10. That's all you had to do, was add 10 to the metric value, where metric name equals births and metric year equals 2012. And that was that one. Now I'm going to run that. Make sure it runs. And it changes one row. And now I'm going to set it back because I don't like messing up my database. So I'm going to put a minus there to subtract it again. There we go. All right, so we're back to where we were. So those were those 2 queries. Okay, write an integrity constraint to ensure that no metric value exceeds 400 million. Whenever we write an integrity constraint, we're doing an altered table. And in this case, we're doing an altered table on population metrics. We call it something no more. $400 million. Jack. $400, 1, 2, 3, 4, 5, 6. Check that that's correct, 400 million. 400 million, good. And if I've done that correctly and we run this, we have a new constraint here that says none of these things are more than 400 million. All right, and the thing that I learned subsequently from one of you is, let me get rid of that constraint. Refresh this. I don't know if this is standard or not, or whether this is something specific to Microsoft SQL Server. Let me delete that constraint. And one of you showed me this, and I wasn't aware you could do this. You could just do that, I believe. Let's see if that works.
There's an extra combo right by metric value.
Extra.
No, that one. Yep, right there.
did this and it worked, I thought. Nope. This didn't work. Somebody did it in an interesting way and I ran it and it worked. So I was surprised that it worked, but I do it my way. My way is the safe way. All right. Let me rerun that query again. I gotta add that constraint back in. Three, six. There we go. All right, so that's how you did that add constraint. And then the next thing was essentially the transaction, I believe. Let's see. Yeah, so the transaction, all you really had to do for that one was download the transaction that I did previously, which you could have found on the Canvas page by where's the transaction? No, I posted it on the Canvas page. There it is. So here's the transaction that I posted on the Canvas page. All you have to do basically was copy this, paste it for the syntax. Or maybe fix the spacing a bit. Fix the spacing a bit. And change the queries inside this thing to be the queries that we were talking about in the assignment. So, you could use this as a nice framework for your query, and just replace the queries in here with the right queries. Since this provides a very nice structure. So I'd get rid of these queries. I'm going to have to restore this database from backup again. And you would replace it with the queries that were requested here, which were a query that inserts this entry in geographic area. So we would do insert into China, oh, right? China, comma. So like that, 90,000 CH. China. No. That would be the first query. Second query is a record, a query that selects the record just added. So select our geographic area where ipsnum equals, I think ipsnum is yeah. Okay, that would be the second thing. And then the third thing was a query that tries to write this into population estimates. So let me copy that. Insert into population estimates, population metrics. Value as don't leave anything out here. When this insert fails, make sure the transaction rolls back and do a full outer join. Geographic area. Full outer join. Population metrics on geographic area dot fits equals population metrics dot fits where fits where geographic area dot fits 500,000. And hopefully if I did all this right, I obviously didn't. Hopefully if I did all this right, nope. Double check my syntax, bear with me. Oh, I forgot to. Oh, the word as is wrong. Sorry, I got the word as in there. Get that out of there. Oh, that's not right here. Values. Any stupid mistakes, can I make them one query? All right, there we go. So when you do this correctly, it will insert it and you'll see it inserted, but then when the next query fails because of the constraint, it'll roll back and that entry will be gone. Okay? So that was the solution to the homework problem. Does anybody have any questions on this homework? If not, that's it for today. I will remind you that you've got a new assignment due, the Java program. And if you're having trouble with that, if you're running into any trouble with that, please let me know and I'll try to provide you with help. But that is due on Thursday. And, don't wait for the last minute if you need help with that. And we will end the class there.